Dear students, today we will continue from the previous lecture. Today our heading is Onsagar, formulation, can be basically summarized in the following statements. The first statement is that the Onsager theory is based on the principle of microscopic reversibility. Which status that under equilibrium conditions any molecular process and a reverse of that process will be taking place on the average of the same rate. The second statement regarding this Onsager formulation is that the thermodynamic equations of motion which we call basically phenomenological laws suppose if J is taken as the rate of flow or you can say flux, which we have already understood in the previous class. And suppose X as the driving force. Then the flux force or driving force relationship is given by, we know the simple relation that J is equal to L into X. Suppose this is equation number 1. Basically this flux, it has a linear dependence or it is directly proportional to driving force. So linear laws of this kind are called phenomenological relations. Okay, this point we have already discussed in the previous class. Okay, now at thermodynamic equilibrium, for all processes, the force is basically suppose X subscript K driving forces and N is the flux or flow, which we represent by suppose Jk for this process in the system is 0. Now when the system is close to equilibrium or near to equilibrium, it is basically assumed that it has linear dependence of J on X. Now if now two or more processes are take place simultaneously, in the same system. It is assumed that each of the flows depends both depends on both the forces or both the driving forces, which basically which are the causes for the flows. So these are basically the two statements regarding this. Now we will consider a system in which the temperature gradient is, suppose x1 is temperature gradient, and also we will consider x2 as concentration gradient. So there will be a flow of heat and flow of matter. So in this case, flow of heat, and in this case flow of matter, but they will be both taking place in the same process. So we also write this suppose as J1 and this as flow of matter as J2. Therefore, according to this Onsagar, if these both processes occur simultaneously near equilibrium, that is both the flow of heat as well as flow of concentration, so these flows and forces are related by the phenomenological equation. Suppose we will write J1 is equal to L11 x1 plus L12 x2. Suppose this is equation number second, and similarly J2 will be equal to L21 x1 plus L22 x2. Suppose this is equation number 3. This L11, it is called thermal conductivity coefficient. Thermal conductivity coefficient, which basically relates J1 with x1, and L22 is simply diffusion coefficient. Diffusion coefficient which relates J2 with x2. These coefficients are shown to be positive. Now the cross coefficients those are L21 and L212. They describe basically the interference